There you go. We're recording. Okay. Thank you for attending, everybody. This will be a class on defect recognition for electrical. The time is 7:02. The date is 11/9/2021. I'm Bryck Gabor. Harris Bryck will be on shortly. He's signing in. Okay, so let's take a look at picture number 1. And item number C is double taps. That's not a big deal, except the fact that breaker's not designed for double taps. So that's your first issue. If you look at the wires, they're of unequal size. Wires of unequal size cannot be attached under the same lug no matter what. Okay, so that's wrong. Also, if you look, it's a single pole 30. So both those wires are in adequate size to be attached to a single pole 30. What size wire do we need? Not number 14, not number 12, number 10 minimum, if we're going to have proper circuit protection. So in the SOPs, it's called compatibility with the protection for the wire. So that breaker would be wrong. Item number B, if you take a look at B, we have the same issue. It's a 20 amp breaker, and we have 2 different wires hooked up. One is blue, one is black. It doesn't matter, a hot or black wire, or a hot wire that's energized, let's call it energized, can be any color except what color? Can't be green. Can't use a green wire. You can use a white wire and mark it, but you can never use a green wire and mark it. Okay. I think that's the only thing we see in here. We take a look way back in here. Do you see the multi-strand aluminum hidden in the back here where my little pointer is? Any place I have multi-strand aluminum, the manufacturer of the panel tells us that the panel cover that it requires antioxidant. And if it says that on the cover, then it's going to need it. So you're going to want to make sure that that's what you're putting there. Okay, this is the panel cover plate that's located on the inside page. Now, if this isn't big enough on your screen, hit plus or minus. Just put your cursor in the middle of the page and make it bigger for you to see. So if you take a look here, line A and B, this is a single phase panel. Line A and B supplies power. So these would be your black or hot leads, and N for your neutral. Over here on the side, this panel cover here shows that it has 40 poles, 40 breakers. Your panels are designed to hold 40 poles plus the main breaker, so that's a total of 42. So I got a call from one of our members of AZ ASHI, and he said the electrician told him that he could have 46 in the panel, and said, why 46? And he goes, well, he likes that number, so he just said 46 was a good number. The manufacturers tell us what that rule is, so that's what it is. Let's take a look at the other one. So here's a Cutler Hammer. Again, you don't have to read the small print, but boy, it sure is nice to read the small print sometimes because it can tell you what you have. So in this case, it's an overhead service. Here's the meter. We come over here, there's a breaker, and then down below we go down. And again, if you make this bigger on your screen, it says 40. So again, this tells you. So if you look into it and you count the number of poles, the handles that are on the breakers, and it's over 40, it's wrong. Okay, A and B. A is correct because we're drilling a hole through the middle of the stud. We're allowed to drill holes in studs, right? Yes.
Yes.
Okay, and the size of the hole can't be bigger than what? What's the size of the hole we can drill out a stud that's under compression from the top down to the bottom plate from the top plate? How big of a hole can we drill? I don't know what it is, but it's not very big. So we know we can drill, it's like a quarter of the size. I'll have to look it up, everybody. But right now, a 5/8 hole for 2 wires is a pretty typical size. And most of your wires are never over 1 inch. Okay. So we'd look and see, but the whole issue here is we can't notch. Okay. And if we do notch, we've got to use nail plates.
I think it's like a third. The hole should not be any larger than a third of the surface area of the stud.
Yeah, whatever it is, something like that. That's a good one, Roger. Either way, it can't be within 1.5 inches of the surface. Let's do it that way. because your screws or your nails would come through. So it's number B. If I'm going to notch an inside corner, I have to use plates, nail plates. Okay. Okay, three-phase. We don't need to talk about this much. It's just showing a wire delta for us for right now. We don't really care. Okay, this is the bus. This is the bus that's inside of a panel. And again, if you want to make this bigger, you can just make it bigger in front of you, so you can take a look. Here, I'll just make it bigger. And you can take a look right here, and you can see the top lug is gone. And this is back when you could replace these in a panel and just pull it out and put another one in. So as I go down this panel here, see how the bus, and this is spelled B-U-S, like a bus you'd be riding in. Bus. As I get down here, these have notches in them. So the notches tell me I can put in tandem breakers. On this panel. But anytime I have heat damage, what does that mean for the panel? Is that repairable? Never. It needs a new panel. It needs to be rewired. Needs a new panel. Okay. Okay, this is a quad. This breaker can fit only in a panel that has a notch in the bus. So if you take a look here, this 30-30 on the outside makes this a 240 volt breaker. The interior here is 50. So as long as it's divided in the middle, if you can see my cursor here, it's divided in the middle. This breaker is designed for two circuits. A would be a 30 amp 240, so this is called a two-pole circuit. And the 50 is a 50 amp circuit, 240 volts. Okay. Now, one of the things about this type of breaker today, I was doing some research, is they don't have a common trip on these. What does that mean? Well, that means if this 30 trips, when it goes upward or downward, I mean off, this metal plate here has to pull the other handle off. So quads are notorious for like being hooked up to a dryer or a stove and hardly nothing works on it. You know, maybe the lights work, but it won't heat. That's because one side of the breaker is tripped and the other side hasn't. So that's why you need to have a volt stick to, check that out. So these breakers are not designed to put a wire that's bigger than what'll fit into these spaces. So a 50 amp here, what size wire can I have in that? Can I have a 10 gauge? Nope. How about an 8 gauge? Probably not.
6 gauge.
6 gauge. So we go to 6 gauge copper and we put that in. They deregulated the sizes before we could have the 8 gauge wire there, but it's only rated for 45 amps. Okay, here we can see burn marks on the front. If any of you are inspecting anything with this type of system, you don't want to get closer than a 10-foot pole. So a 10-foot pole is where that term came from. As you're being shocked, you want to make sure you're far enough away not to get damaged. Okay, so this all burned out, and that's a problem. So I put this picture on our website, and it was removed as being too violent. It's not real, but they removed this. I'm sort of surprised. So this is a dummy, and he's flipping this handle. He's cranking to shut it off, and the arc flash is coming out so fast. He doesn't have a prayer to get out of the way. It overwhelms him immediately, and the next thing is he's dead. So anytime you're dealing with this type of item, you can see here, you have to wear a face shield and protection. Okay, so none of you should be disconnecting any commercial. Okay, what's wrong with this 3-phase panel? So take a look at it really close. I'm going to make it bigger here. So one of the things about doing inspections is, damn, Okay, so here's a fuse right here. Here's a fuse right here. And here's a fuse right here. So here's a hot wire or conductor. Here's a wire probably being used. It is hot because it's hooked to and I have a bare ground wire hooked up to the 3rd phase, the 208 phase. So luckily this thing's not touching anything metallic. If it did, everything would be energized. Like this handle, in any part of the case you're touching. So this is a case here where, and right now the handle's off. See how these right here are pulled out? So it's off. The handle's down right here. Here's the handle. So when you walk up to these type of panels, you got to make sure you always touch the panel with the back of your hand. The back of your hand, okay? Just sort of slide your hand across it, and don't grab it with your arm, because if you do, they're going to have to pry you off with a 2x4 on these type of things. Residential 3-phase panels don't have an auto lockout, meaning I can just open the door on these. All commercial applications that are 3-phase, you can't open the door. It has auto lockout, okay? Okay, this one here is a lot of focus, but doesn't matter. So this is a 300 amp service. Okay, so if you take a look at this, you can look here and see it has this huge meter base up here. Here's some connections up here that are typical with this type of brand. But there's a main breaker here on the right, a main breaker here. So the manufacturers have made panels that can't have more than 2 disconnects. 2 disconnects. So the manufacturer can make a panel that has 2 disconnects. So the interior is controlled by this breaker here, and the exterior is controlled by this breaker right here with breakers below it. You can see it has all these breakers here, and here it has a lug shut off here running somewhere. So this type of panel, if you don't know what you're looking at, you probably should say an electrician should glance at this thing and see if there's anything wrong, because there's just so much stuff here. But there's 2 disconnects in this one. Okay. Okay, what's wrong with this picture? I'm in a bathroom. Can I run an extension cord through a wall ever? No. Yeah, never. So, but I do have lots of plugs here, so this is probably better than nothing. Okay. How many circuits are in this fuse panel?
It's like 8.
Yeah. So here's 1, 2, 3, 4, 5, 6. All these down here aren't screwed in. You have to zoom in. So let's zoom in now. This is a case where you take a picture and you're going, what the hell? Okay. This is a transformer mounted inside the panel. Can I mount a low voltage transformer ever inside of a high voltage panel? The answer is no. No. Oh, you're all trained so well. The answer is no. So this is good. This old panel here is a knob for knob and tube. And back in the good old days, they ran a wire for the neutral and a wire for the hot. Okay, so if you look, I got white wire. There's no colorization here. So one of these fuses is running the hot wire to this transformer, and the other one's running the other wire to the transformer. So we're fusing the neutrals. So we actually have 1, 2, 3 circuits for this house with knob and tube. You shouldn't be unscrewing fuses, but if the house is vacant, the way to check this is unscrew this fuse, lights go out. Unscrew it and then put it back in. Unscrew this fuse, and the same lights go out because you're fusing the neutrals. This is extremely unsafe because all devices today are polarized. And the polarizing is there so that the switch is always in the hot side of whatever you're shutting off. Okay? Anybody have any questions about this mess here? So when you have this one here, you can just stop. You don't need to spend a lot more time writing down defects. This type of system here is antiquated and unsafe, is wired. Fusing the neutrals is unsafe, and a complete upgrade of the system. Hey, Brad, you must have dropped your phone out the window. Thank you. Werner doesn't look like Harris, but okay. Hey, Werner, thanks for coming on. Okay, so take a look here. Green fuses are for what size wire? They're 30 amps. So a knob and tube, what size wire is that? Is that wire ever number 10 gauge wire? It's not. It's the size of telegraph wire in 1890, which was 12 gauge. and 14 gauge. So they took telegraph wire, which they had. So it's sort of weird. That was determined for us in the 1800s. And then we just used the same wire wrapped with some other product. So green fuses, this is called an Edison base fuses. Edison, see right here, see how big the base is? That's the size of a light bulb. So I shouldn't tell you this, but if you run out of fuses in an old house, I can take a light bulb and screw it in and make the circuit work. That's called an Edison base fuse. Okay? In the past, they throw a penny behind there, screw it back in, and the penny would MacGyver the hell out of it, and it would work. Shouldn't show you that. But either way, that's what MacGyver did. Okay, so here's what's the amp size of the fuse at letter A? So I told you, based on the color, what is that? 30 amps. So we already know it's wrong. And that's 120 volts. So they're colored green. So they made it so in case you can't read, because many people couldn't read back in the 18 or 1900s. If you're colorblind, well, you're screwed because you'd have to read it. Okay. So this has a pull block. Look right here at the bottom where there's a pull block there. And usually that pull block was for running 240 volt things. There weren't many of them, but mostly the electric stove. So that circuit would have been the electric stove right here. Okay. Okay, here's a close-up of our wiring. Now I want you to look at this. Is this cloth covered?
Yes.
Is cloth covered? So can this wire that looks like aluminum be aluminum if it's cloth covered?
No.
The answer is no. Never. If it's cloth covered, we know it's what, Roger?
It can be tinned copper.
Yes.
Or copper tinned, or however you want to say it.
Well, it's whichever way you'd like to say. It's clad with tin. It's copper.
There you go.
Tin, yeah. And the reason they use tinning agents is tin was really hard to make wires with. It was very expensive, but it stopped the wire from oxidizing. So when you see copper wiring and it's green or black, you get scared. Well, yeah, you write it up and say this wire doesn't look like copper anymore. So back then they tin that. So if you're in a boat or near the ocean and you buy wire to use, it usually looks just like this. But either way, this is copper clad with tin. So it's not aluminum, okay? And then these fuses here, you can see the cover's gone, so you can't tell what they are. Hey, this one's green, so they're probably 30 amps. Wait a minute. I thought 30 was too big for this knob and tube wiring. The answer is yes. And the reason they put it in, it won't trip. See? That was easy. Okay. Why are the neutrals fused in this panel? Well, let's zoom in here again. I should stand closer. Okay, so when I see piles of fuses laying on the bottom, it's usually a good indicator that I'm blowing fuses like there's no tomorrow. Here's a transformer. And do you notice how both wires are hooked to the fuses? That's the giveaway. I'm telling you. When a transformer is hooked up to each fuse, they're fusing the neutrals throughout this house. Okay, look up here, right here at the top. I don't know if you can see the little hand. Does that show up on your screen?
Yeah, a little bit.
Yeah, okay. So I'll just move it around a little bit. So there's a little hand there, and at the top of the screen, that's called loom, L-O-O-M. It's a braided cotton product. Whenever the knob and tube goes through metal or wood or something, loom is used, and the knob and tube that they talked about is ceramic holders that are for that. Okay. Well, Harris keeps texting me and saying, how do I get on? But we sent him the information. Well, maybe he's not at a special place. Okay. Sorry. We sent you the link, Harris. Or I could call him and just have him talk in the background. We sent you the link. There you go. Okay, maybe he'll call me in a minute. Okay, so back to this panel here. Is this panel unsafe? Yes or no?
Yeah, yes.
Okay, there we go. It's very simple. Yes. So at this point, we need an electrician to give you options for replacement of the panel. It's very simple. Okay, now, I want you to take a look. We know it's knob and tube. I can see it here. We're fusing the neutrals. That's dangerous as hell. There's nothing more dangerous. Dangerous, dangerous, dangerous. That means when I flip off the switch, if I touch the light bulb, which is off, and I'm grounding myself, I could be switching the neutral, meaning there's still a path to ground. I could be shocked. And I remember living in an old house, replacing a light bulb. I touched the sink, and damn, did I get shocked. Okay, so here's a piece of Romex coming in, and they didn't have enough space, so they're just tapping it in, double tapping here to the doorbell. And after all this, I bet the doorbell doesn't even work. Okay, let's take a look at this one here. First of all, I have a solar dryer right here, this round thing here. Okay, there's a solar dryer. And then right over here is my main disconnect. See it right here? So this has fuses. So when I have a knife type fuse, what's the smallest size I can have for our intended purposes? Could that be a 60 amp service?
Yes.
Nope.
No.
They don't make a 60 amp knife blade. So when I have those knife blades like that and I can grab it and put it in, that the minimum size, they make a 75, but for our intended purposes, this is what size?
100 amp then.
100 amps. 100 amps. There it is. Okay. So the round one that looks like a roll of dimes is our 60. And I can see it's braided here with, again, it looks like aluminum. That probably is aluminum in this case because it's not cloth covered. So we can look up here at our meter base. It's round. And then our meter base up here has the smaller pipe. Remember, the minimum size service is what size for insurance companies today? 100 amps. 100 amps. 100 amps. Okay, here's a light bulb. Here's a fixture. It's got a chain pull. It's one of those ceramic. Is that rated for outside use ever? No. The answer is no. So that's wrong right there. It's not waterproof, not water resistant. Then I see like a compression, and I got EMT coming down the wall. So I like it. Okay, are there one or two disconnects in this panel? Well, let's pretend you saw this one earlier and your memory is impeccable and you can still remember from before. So I see two of them. This one here, where my little hand is, controls what's below it. And this one over here controls a panel inside the building. So there's two disconnects. How many can we have from a manufacturer? Two. The code's always been I can have up to 6 disconnects, 6 ways to shut off the power to a building. So we can have buildings built 20, 30 years ago that have 6 disconnects, 1 meter and 6 disconnects. Now, in this panel, what's the problem with the panel? What's my requirement for the door? How much room do I need in front of it to view it?
Oh, 3 feet.
Okay, thank you.
30 inches?
Yeah, thank you. Now, the air conditioner is required to have so much space. Does it have enough space?
No.
Probably not. So we'd write that up. So I got two issues here, and everyone goes, well, you're making them move the compressor and the outside unit. Well, I'm not making them do anything, but I'm going to write it up. So there's some sort of wooden thing here. It's not wooden. This is the gate. See, here's the gate latch right here, and here's the gate here, and then the AC is like right here. These new units are like a foot or two bigger. And so I just write them up because they're required to have like 12 inches on each side and 30 inches on at least one side to get into the unit. So, you just write them up. Okay, this one here, let's take a look. Is letter A 100 or 240 volts? Letter A. It's a brand that doesn't have 2 handles. It has one, but it's a big fat breaker. So that's 240 volts because when it's that wide, it covers the bus from one side of the panel to the other. So that's 240. So look right here. They used a white wire and they designated it as black by wrapping it with tape. That's allowed by the manufacturer and the code. What's unusual about this picture, if I look through the panel here, if you notice there's no grounds or neutrals on it. This was weird. There's no grounds or neutrals. Let's go down at the bottom one. Oh, here's like a ground. Here's a ground, green for ground. Oh, hey, Harris.
Hey, Harris.
Hi.
We've been waiting for you.
Sorry, buddy. She was supposed to send a link to you and she didn't, so she's bad.
Okay.
Okay. So Harris, we held out. We've only looked at a couple of pictures. Don't worry.
Okay.
Okay. So Harris, why don't you tell them why this brand is big like this with this one handle?
Okay. That's a square D breaker. And you can tell by a few things. One is the actual name on it. Two is if you see where it says off, if you look above it, there's a little glass window. And in that glass window, you'll see a green or red. Green means the breaker is on, red means the breaker is off. And that's an internal trip breaker. So sometimes the handle doesn't move and the breaker could be off. So if you look in that little window and it shows red, you know that the breaker has tripped.
Harris, where the letter B is, am I allowed to tap into one leg of the 240 on the breaker?
No, you're not allowed to do that because now you're actually have an imbalanced load. So no, that's not allowed.
Okay, I heard you say imbalanced load. Was that really what I wanted to know, or just is the answer no?
Well, what's happening is you're putting extra amperage on one leg, that's an imbalance, and it can cause the breaker to trip.
Okay, so are you telling me I need another breaker?
Yes.
Thank you. Okay,
It's no good.
okay. So the extra wire there needs to be on another circuit. Now, do we need to have an electrician determine which one of those wires needs to be on a 120 circuit?
Well, of course, you just have to trace out the cable to see which is a pair. They go in the same Romex cable.
Okay, so right now this breaker is a 240 breaker, so we have one circuit that's 240, and the double up one is 120 using one side of the breaker.
Right, and that's not allowed.
It's unsafe?
Unsafe.
Unsafe. Okay, here we go. And Harris grew up installing these panels.
Yeah, that's a Federal Pacific panel, and it's a 2-pole breaker. And obviously it's double tapped on one leg, and that's no good. That screw is not made to handle 2 wires. Okay, so it's not a legal hookup.
Now, when you say legal, I want to write up a report. Do I use the word legal, or do I say this is an unsafe connection?
You say it's unsafe, fire hazard, double tapped.
Okay, and do I need to have someone that has a skill set to repair this?
Well, an electrician should make all the necessary repairs.
Okay, so somebody who knows something about electrical, like an electrician.
Right.
Yeah. So Harris is an electrician, for those of you that don't know. So I'm not trying to insult him. I'm just saying that it should be an electrician. Okay,
Yep,
Harris,
yep.
I wired this up a couple years ago, and I thought I'd take a picture of this. It's camouflaged.
There are 2 things wrong with this picture. One is that it doesn't look like it's UF wire, which is underground direct burial wire. And number 2, it's not terminated properly in a box.
Now, when you say UF, how can you tell just by looking at that?
Well, typically UF wire is gray in color. It's a dark gray, and that is not a dark gray. That's white.
Okay, so
Typically, I was going to say typically standard Romex is white, although today it comes in colors.
okay, it says there's 5 items wrong, so you got 2. What are the other 3, Harris?
Well, one is you don't have a conduit coming up. Like I say, conduit into a protected box with a waterproof cover and a rain-tied box.
Okay, so there's 3. And what's the biggie here on having an outlet out in the yard?
Well,
GFCI.
There you go.
GFCI.
Said that. You're the winner
Yo.
tonight. You get the winner.
Who
Chicken
beat me? Who beat me?
winner chicken dinner. Okay, Harris, that outlet, is that a polarized outlet?
Yes, it is polarized. You could see one wide, slot and one narrow one,
Okay.
and a ground slot.
So, Harris, I for extra credit, anybody who can yell this out before Harris, there's Mickey Mouse ears hooked to both ends of that outlet. What is that called?
Yoke.
Yoke. See, Harris said it already. That's called the yoke. The yoke of the outlet looks like a Mickey Mouse here. And that's called the yoke.
Mhm.
Is it spelled? How's it spelled, Harris?
YOLK.
Like the yolk of an egg?
Correct. Same thing.
Yeah. Okay, everybody. So extra credit. You can say that tomorrow. Okay, here we go. Is this water main bonded or grounded, Harris?
Well, the only thing we can go by that is It's got a wire on it. We're not sure. It could be most likely a ground because it looks like a water pipe, but it's not a bond because a bond would go to a gas pipe.
Okay, so for our purposes, we're required to write down the location of the grounding wire location. Is that part of our SOPs?
It is, yes, it is.
Okay, so is it grounded or bonded?
That happened to be, that is being using the pipe as a ground.
Okay, so I can use a pipe, and what other two items can I use?
You can have a main ground rod and a supplemental ground rod and a U for ground.
Okay, and a U for ground is what?
U for ground is 20 feet of rebar that's encased in concrete in the foundation of a house.
So you'll see that mainly in new construction.
Yes, mainly in new construction.
Okay, so when we inspect a house and they say we've replaced the galvanized pipe, there's no longer pipe there. So what should we see on that service now, since the main's been replaced?
Well, you should see a sign that says a plastic pipe has been installed, and then you should see a couple of ground rods installed for the ground.
What would I look for, Harris?
Well, if they install the ground rods right, you don't see them. However, you should see the wire coming down from the panel into the ground.
Okay, and am I going to look for, let's pretend they are correct, but they're still sticking up out of the ground. What should I see? Two rods sticking out of the ground somewhere?
All right, 2 rods sticking out of the ground with solid brass connectors.
Okay, and are they a certain distance apart?
8 feet apart.
Okay, so you mean 6 feet minimum?
Well, more than 6 feet, but typically we set it 8 feet apart. Gives you a better ground source.
Okay, yeah. So the code in Arizona is the rods are 8, but the 6 foot separation on grounding rods. Okay,
That is correct.
Okay, so let's go to their next one here. And Harris, why is the ground wire attached to the fuse? Cool.
Well, it shouldn't be. That's not right. It's an uninsulated conductor. Number one, you can't use a ground conductor as a current carrying conductor. Number two, it's undersized compared to the other 2 wires because grounds only have to be a proportionate size to the current carrying conductors.
Now, see, Harris knows too much, everybody. So he's telling you something we don't even care about because this is like totally unsafe as connected. Is that right, Harris?
Absolutely.
Okay, yeah. So in our case, we don't even care that the wire's undersized. You just can't hook a bare wire directly to a hot feed. Right, Harris?
I said that at first, and yes, but I
that's
gave
okay.
a little further explanation.
But he couldn't help himself because his head was exploding, wanted to give you more electrical. Way to go, Harris. I love it. Okay, here we go. Harris, look at this one. This reminds me of when you wired up that panel for me back in 1950.
Yeah. Oh, yeah. It looks like one I worked on.
Yeah, there you go. Okay, how many circuits are in this panel, Harris?
Well, it looks like you have 6 circuits.
Okay, now could I be fusing the neutrals, or do I have 6 circuits?
Now, those are 6 circuits because if you notice, all the neutrals, all the white wires are hooked to a center bus bar. And that means that center bus bar is the neutral connection.
Running down the middle. Now, Harris,
Right.
for extra credit, does this panel have 120 volts or 240?
This panel has 120 volts.
Is that because this jumper at the bottom jumps from one side of the bus to the other?
That's right.
Okay,
Yes.
so everybody zoom in, hit your plus and minus on your screen, get real in there close, and you notice here they brought up this little bitty wire, and oh yeah, it's UF cable. Someone stripped it back like a half an inch and then tried to stretch the wire to get it up into that screw there. And Harris, these fuses we see look like they're Edison based fuses, Fusetron, and what other brand?
Right. You have a Fusestat. Fustron is a brand.
Mm.
That's an Edison base, and that is a dual element fuse. Fustrons are a dual element, meaning it can start a motor. And the blue one on the bottom left is 15 amps. It's just a standard fuse. On the top right is a 25 amp fuse, and that's just a normal ordinary fuse. And then, of course, you have an orange one down the bottom, which is 20 amps. And one in the middle looks like it might be another orange one, which normally tells me they're all overfused because all the wiring in that panel most likely is number 14.
Okay, so does everybody understand? Fuses are too big, correction needed. Now, Harris, would you say to me that this wiring panel is antiquated by today's standards and replacement may be needed?
Well, yeah, replacement is needed, definitely.
Oh, okay.
There's no in-betweens.
Harris has changed. He used to say, "What's the big deal? Let's just come on." Yeah.
Yeah.
Okay. Okay. Harris, I took this breaker and I took a picture of it. It came from a panel I wrote up, and I got there and the lights were blinking in the house. They'd get dim and I can't believe it. The circuit was still working. But it's a 240 circuit, and it was next to the other breaker. So it wasn't the breaker that was bad, but the lights kept dimming and then getting brighter in the house. Why?
Well, what happened was, the breaker that was next to this one was catching fire. It was overheating, and it actually melted the connection in the breaker next to it. It was a fire that had started.
So is an inspector,
you can't see it.
Okay, so as an inspector, if we hear buzzing in the panel, lights blinking, lights dimming, we need
You have a problem.
We have a problem. Thank you, Houston. Okay, everybody. Okay, Harris, here's it. So all these breakers have these like labels on them, everybody. And everyone says, I can't read it, but you all have phones. So you just take your phone and you take a picture and then you just make it bigger. Harris, tell me what I'm looking at. Start at the top here. One pole.
A single pole type QO, and it says 1 or 2 aluminum or copper from 8 to number 14 wires, 120, 240 volts AC.
What's VAC mean? Harris, what's VAC mean?
Alternating current. Okay. Of course, here in the United States, not all over the place, but most of the time you'll find alternating current. There are a lot of areas that has a lot of motors that they use DC current.
Okay, for our purposes today and for the rest of the century until the end of the year, Harris, as home
You're not going to find DC.
Thank you. We don't care. All we care about is AC power for all of you that are online tonight. Thank you.
Right, but the other big thing is when it says VAC, volts AC, this breaker cannot be used on a DC circuit.
Harris, when was the last time you saw a DC circuit anywhere in Tucson?
Never.
Thank you. How about Phoenix? Phoenix? Okay. Yeah, you're not going to find one. So again, we're looking for the elusive Yeti or Bigfoot or something. Okay, here we go. Harris, this one's a little bit different.
Yeah, it's called a lug, LUG. And the 600 MCM, the other numbers don't go with, that's just model numbers, but 600 MCM-4, it'll take a 600 million circular mill, MCM, million circular mill, to a number 4 wire, or 2 number 250 million circular mill wires, or 1 1/0 wire, and aluminum or copper. So in other words, that particular lug will handle more than 1 wire. It's listed for 2 wires.
And it has the number 2 on it, meaning 2 wires.
Right.
Hey, there you go.
250 MCM or 1/600 MCM. Okay. MCM is million circular mill.
Again, that's something I like to know, but I don't care as an inspector right now.
It's a big wire.
It's a big wire. Thank you, Harris. Thank you for that knowledge. I'm going to use that all tomorrow. And the weird thing about this writing, it's on the bottom side of this connector. So when it was bolted into the panel, you can't read any of this on this case. So I just thought I'd give you that. So here it is. This is this.
Right. It's on the side of the lug.
It's on the side right here of the lug. But if this is hot, in other words, there's a wire in it, you can't get near it. You touch it, you're going to get electrocuted. So have
That's
someone,
true.
yeah. So have someone shoot a video when you're playing with it. Okay, this one, you know, we used to see this all the time. We were working with evaporative coolers, and since I don't see coolers much anymore, but Harris, this letter A, what's wrong with this extension cord wire?
Well, what's happening is the outer coating was dried out and cracked and peeled off from the sun. So it has to be replaced.
Okay, so bad. And then B, can I have a box like this with this type of interior plug exposed to the weather?
Not any longer. It's got to be shielded from the weather.
What do you mean no longer? Longer than what?
Well, when they installed it way back in the 60s and 50s, it was allowed. However, they've changed the codes and now it's not allowed.
Okay, most of the people online tonight weren't even alive back then. So this is bad, right?
It's bad.
Thank you. Okay, so number C here, I have a screw-on type plug here in the top here.
Right. That is an approved type plug and it's watertight.
Oh, okay. And how about D here? Am I missing something that's where a pipe goes through the roof?
You look like you're missing what's called a roof jack.
Huh.
The roof jack is, a seal to the roof where the pipe penetrates the roof.
Okay, so you're telling me I can't just punch a hole in the roof, stick a pipe in there, and put some tar around it and be done with it?
Nope, it's got to have a roof jack because of expansion and contraction of all the materials.
Okay, so if I couldn't remember the word roof jack, could I say I'm missing the flashing around the pipe entering the roof?
That's another word for it.
Flashing. Okay, very good, excellent. Okay. Oh man, this is a mess. Okay, Harris, as I look at this picture, okay, A, what's wrong with letter A?
Well, A doesn't have a formal clamp or a connector holding the two wires together. What somebody did was they spliced it and wrapped it with tape.
Okay.
Not allowed.
And it's laying on the roof for those of you that can't see.
Right.
Okay, so is this the way wires used to be run to the house? 3 wires separated and then hooked to a ceramic?
Yeah, that was the way that the power company used to supply power to the house. And of course, it was later replaced with stuff called triplex.
Okay, so when I see a service like this with 3 wires, would I say a service upgrade's needed and call an electrician?
Oh, absolutely, yes.
Okay, so I can stop with all this other stuff. Is this right now based on these wires laying on the roof and wrapped with some sort of electrician's tape? Is this unsafe?
It's unsafe right now, yes.
Yes, thank you. Okay, I like lights on both sides of the door, and I like to put them just low enough for the door to hit them. Is that okay, or should they be above the door?
Not okay. The wires are not properly protected from physical damage. So they have to be enclosed in conduit.
Okay.
And also there are no junction boxes behind each fixture because they're laying flat on the wall. And they would never lay flat on the wall if there was a junction box there.
Well, I see tape on it here. It's taped together right here in the air.
Yeah.
Okay.
Yeah. No good.
No good. Okay. So here's an outlet on the wall. So it looks like they plugged in the lights to this outlet and then it's switched inside and then it comes up here and there's a wire running across the rafters. So this would be a bad thing.
Everything is bad in that whole installation.
Okay. So we're going to write this up as an unsafe condition. Electrician needs to repair properly.
And not only that, the receptacle that's on the wall is not in a rain-tight box or rain-tight cover.
And does it need to be GFCI protected as required for all exterior receptacles below a certain height?
Yes. Yes.
What height would that be, Harris?
Anything under 8 feet has to be protected.
Okay, so if I can touch it, is that bad then?
That's real bad.
Okay, so if I can touch the outlet and you can't decide what 8 feet is, everybody, we'll make it easy for you. That door is 6'8". That's the standard height of every door on the planet that's not 7 feet. Okay. So if you see an outlet and you can touch it and it's outside, it needs to be GFCI. Is that correct?
Now, one other thing, even if it's under a patio,
Like right now?
that's considered a damp condition, and it still needs rain-tight equipment.
Okay. So if it's outside the living space, that's still outside, right?
Right.
Okay. So is this plastic receptacle okay with no electrical box?
Well, you don't have, again, no junction box for a safe splice. That is not safe. It's a fire hazard. It's illegal. Of course, we don't say too much of that. We just say it's a fire hazard, needs to be replaced.
Harris, I want to write a report. Am I going to write illegal? What am I writing?
Oh, no. You're going to write that they have splices that are not properly terminated in the junction box.
Okay, so you don't say, so Harris, let me ask you a question. So you just don't say there's an unsafe wiring on this light, get it fixed. You don't say it that way. You say what you see, right?
Right. In other words, they're not properly terminated in a junction box.
Okay.
That answers your question.
Yes, thank you. So when you're writing up a report, Roger, you're part of the AAC, right?
Yeah, the Enforcement Advisory Council.
Yeah, right. Yeah. So if someone writes down and says unsafe wiring needs to be correct, and that's all they say, is that going to meet the requirement for writing a correct report?
No.
Okay. So you got to tell us what it is, where it is. Huh?
You got to give them a little more direction, a little more substance.
Yeah. Tell me why you think it's wrong, right?
Mm-hmm.
And then who should do something about it?
Yeah, some reasoning, the implications.
Okay. Harris, what were you saying?
Saying if you put down not properly terminated in a junction box, that gives you direction.
Well, let's pretend I don't know what you just said to me. When you say not properly terminated, I don't know what that means.
Well, that's why you have to hire an electrician.
But I don't even know to write that. So how do I write that in English as a report writer? Not terminated. What's the other word I can use? Some words. Give me some words.
I always use terminated.
I know you do. So what would you say? The wires need to be installed.
Not properly spliced in a junction box.
Yeah, or installed in a junction box.
Right.
Yeah, okay. Yeah, Harris and I speak two different languages. He speaks electricianese, and I speak inspectorese. But either way.
I speak lucky. I'm lucky.
Yeah, you're lucky. Okay. Okay, everybody, take a look at the service here. And Harris, one of the things about the service here, when it gets really tall like that, do I need to have supports on the back side of it here?
Any riser pipe, and that's that 2-inch pipe that you see there, that's more than 2 feet above the roof, needs to have support opposite the direction of the input wires.
Okay, so let's make it easy for everybody. This pipe is 2 inches. It is. When it's more than 2 feet, so 2 inches and 2 feet, I need support. Is that right, Harris?
That's right.
There we go.
Right. Anything more than 2 feet.
Yeah, okay. Now, why is this so high? Why did they make this so high? What do you think is off to my left here?
Probably a driveway.
A driveway, okay. And maybe it's a street or something because it seems really high to me. So when I'm going over a street, do I need to be really high?
18 feet.
Like an alley. Oh, like an alley. Okay. So that's probably what that is. Because a driveway at a house only has to be what? How high, Harris?
12 feet.
12 feet. Okay, here we go. I don't know what this is, but it looks like a mess to me. Well, they put tape on it, so it must be okay.
Well, what it is, you're looking at the back of a fixture. That's a fixture bar.
Uh-huh.
And they place the wires without a junction box. And it's a fire hazard because it's not terminated properly in a junction box. It's not connected properly in the junction box.
Yeah, I'm going to terminate you right now. I'm the Terminator. Oh, there we go. I'm the Terminator. Okay.
Hey, Terminator.
So this wire is installed behind the molding of this window frame. So seeing that, would that be bad, Harris?
It's very bad because it's not enclosed in a conduit or some protective coating.
Okay,
Covered.
excellent, excellent. I'm not sure what this picture is. I think it's a spliced wire, so we'll skip it. Okay, here I am at some new construction, and we're inside of an attic, and I see a fuse here and some sort of outlet here, and then I see a plug here going to the furnace. Why would I have a fuse right here?
Well, that's an SOY, and the reason you have a fuse protecting your furnace is because UL tested the furnace under those conditions where there was a fuse in the line, and you have to replicate it on your installation when you put it in the house.
Okay, you said UL. I don't know what that means.
Oh, the underwriter's laboratory, when they test equipment, the way they test it, you have to install your equipment exactly the same way for the UL protection.
Oh, okay. Now I see some staples here with this wire. Are you required to staple this wire like somewhere near the box it's in?
Usually within 6 inches of the entrance of a box, you need to have a staple on either end.
So I'm missing one over here.
Right, you're missing one on the other box also.
Yeah, I'm missing one here. I only have it here. So maybe they ran out of staples and they can only put them in 2 spaces.
Right. You could always bend a nail over, right?
Yeah, he doesn't mean it, everybody. He's making fun. Okay, this here, I like to pick up wires and stuff from inspections. So this wire, the electrician just threw it on the ground like it meant nothing to him. But it's all oxidized and the insulation's melted all the way back. So when I have wire that's been on fire or heat destroyed, how far back can that destruction go on the wire, Harris?
Oh, it can go 10 feet back. I mean, it travels through the entire wire because metal conducts heat. And so that travels backwards, and it could even be, 10 feet, maybe even longer.
Okay, so when we do an inspection and they say, yeah, we had to replace the panel, and you look in, you see any bubbling on there, that means that wire's most likely damaged behind that insulation.
Right. It's no good. It should be replaced.
Okay, so bubbling in the wire insulation, the outside cover, is bad.
Right.
Okay, I really don't care, but what is this product made out of? It has some sort of name. Do you know what it is, Harris?
Well, that is just THW type of an insulation, thermal heat resistant wire. And it melted because the wire got too hot.
Sure. Okay. So the name he used, can you say it again? THW?
THW, right. Thermal heat resistant.
Yeah. Okay. Electricians like to use a lot of letters. They can.
Well, the reason for that is you can have 4 wires of the same wire size that have different ampacities depending on the insulation that they put on the wire.
Yeah. Do I need to know that to be an electrician?
No. Well, to be an electrician, yes.
Yeah, I tricked him, everybody. I tricked him. He thought I was going to say to be a home inspector. But very good, Harris. Let's go to the next one here. Why? Okay, this outlet, is this going to be an older type receptacle?
It's going to be a burnt receptacle.
Okay, so this one's burned, and most likely that burn mark occurred. Why?
Well, because of a loose connection.
Okay, so when I have a loose connection, what's the mechanism of why it burns?
Well, the main reason is a loose connection creates resistance. Resistance gets hot when you have a lot of power going through it. So whatever you plugged into that receptacle, all the power that wanted to surge through the wire now has a resistance in the way, and it could arc. And when it arcs, the arc could be 5,000 degrees, and it can cause that to burn up pretty quickly.
Okay, so they have some device now that they want us to look at. It's called an arc fault. Is that what would fix this to stop this from happening?
Yeah, that never would have happened if there was an arc fault circuit breaker installed in the circuit.
Wow, cool. Okay. Okay, this is knob and tube, Harris.
Right.
Okay, do you write knob and tube up as needing to be replaced?
Yeah, the knob and tube wire at this point in the game is so old and so brittle, it is a fire hazard, it's dangerous, and it should be discontinued and replaced.
Okay, so right up here in the middle, you can see it's actually come loose from the knob. So these are knobs, and tubes are where it's going through it. But they're running parallel to this, so one of these is hot and one is a neutral?
Right. And back when they installed this, they weren't sure what was what. So the white could be alive or the black could be alive.
So Harris, how do you determine which one's hot?
Well, if you have your little non-contact tester, you could test it that way.
Oh, okay. So these little non-contact things, you just wave it around and it goes beep 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 and tells me there's power in it.
That's correct.
Oh, okay. So some inspectors say, "Oh, why would I use that? Whatever. It makes noise, and I like tools that make noise. So that way you can tell that it's still got power to it. And so, can you leave this in place and then add new wiring, Harris, and then disconnect all this stuff?
No, you can't. You can't reuse any knob and tube. It has to be discontinued completely. You can't add on to it. You can't shorten it. You can't do anything with it but replace it.
Okay. So if I rewire the building, do I need to remove that wire, or can I just leave it there and disconnect it?
Well, you could leave it there and disconnect it. It doesn't have to be removed, but it cannot be alive.
Okay, so all of you as inspectors, you need to take out your volt stick and wave it around and touch those wires. I don't know how many times they've said, we've rewired the house, there's nothing hooked up, and this wire is hot. It has power, so they're shocked when they hear that. Okay, here we're going to come back into the century. Okay, Harris, we're backfeeding the panel with a 100 amp breaker on the left side.
Right. Top left breaker, if you look closely, you'll see between the two big terminals a screw. Every backfed circuit breaker panel needs to have a screw holding that main breaker in place to secure it properly into the panel.
Okay, and how did we know that this was the main breaker supplying power to this panel?
Well, because if you look up high, you see two lugs up on the top of the panel over the breakers. Right, two lugs, and there are no wires there. So the main feed is coming in through this main 100 amp breaker. Again, but signified by a screw holding it in place. That is your main breaker.
Okay, Harris, when I look at this panel here and I want to find out most panels, can I have a panel before you got on? Can I have a panel with 46 poles?
46? No. 42 is max, including the mains.
So you're telling me that the manufacturer just can't like make a panel with 46 mains and say,
Nope.
Okay, so if I want to count the number of poles in here, this first one that's 100, is that 2?
That's 2.
Okay, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on this side. Is that
Right.
correct?
That's correct.
Okay, now I'm going to go over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
So that's 26 circuits.
26. So can I have 26 in this panel?
Well, you'd have to look at the door of the panel to see if it allows 26. It may be a 1224, which means 24 is the maximum number of circuits allowed in the panel, in which case this is not a good panel. It's not legal.
Okay, so again, it's unsafe. So up here, I have these twins right up here. See these two here and these two here? They may not be allowed at that location, but they've broken off the safety tab and plugged them in anyway. So generally, 1, 2, 3, 4, 5, up to this point, they allow the first 5 to be installed. We don't know that. So Harris will look at the panel cover and read the chart thing. What's it called?
Right, the directory.
The diagram there on the door?
Right.
Yeah.
There's a directory on the door and it tells you the size of the panel, what it's rated at, and how many maximum circuits you're allowed to have in it.
Cool. Okay. So in this case, this panel box has breakers installed that are not compatible with the panel. An electrician needs to correct it. So before you got on, I got a call from a home inspector, and he said the electrician told him that that panel's designed for 26. They could have put, or 46. They could have put 50 in there if they wanted to. Is that any of that statement correct?
None of it is correct.
Thank you. Yeah. Okay. Harris, I'm going to come over here to the right side, and there's a bar here And as I come down, I see one white wire under a lug. I see bare wires under a lug. I see red wires. Red. Is red okay to be hooked to breakers?
Yeah, red is fine. The only colors you can't use on a circuit breaker are gray, green, or white.
I thought I could use a white wire if I designate it as a hot wire.
As long as it's indicated as a color, either with marking pen, with tape, with paint, as long as it's not white, you can use it.
Okay, excellent. And when he says paint, this goes back to the good old days when they got the little jar, a little brush in it, and they would paint the wires individually.
Yep.
Okay, Harris, can I mount a panel on its side like this?
You're not allowed to mount a panel on the side. And because if you look at the cover, it'll say horizontal or vertical. And
Okay.
if it doesn't say vertical, you cannot install it like that.
So
However, there were certain panels that you could install like this, but you couldn't install any breakers on the top. You see, we have 2 breakers on the top. Yeah, those 2. You wouldn't be allowed to install any breakers on the top because
Harris, I'm just going to try to zero in. Why?
I'm just going to explain it to you.
I know, but I'm trying to get to that point. Why? The handle has to do what? Go ahead.
Okay. The circuit breaker energizes with the handle up, and gravity pulls it down to shut it off. In the top breaker, gravity will pull the handle down to turn the circuit breaker back on again, unintentionally.
That's a lot of words, but I like the way you said it. Thank you, Harris. So on a breaker panel, breaker should be down, off, and up, on.
Right.
Now, I see a lot of panels where the breakers go right to left. Is that okay then?
Well, right to left is okay. Again, they have to be only in on the bottom,
Yeah.
not on the top.
Okay. So, but we have panels where all the breakers sort of face inward and then they're off outward.
Inward and outward.
Yeah. In other words, when they're on, they're all facing towards the inside of the panel into the middle. And when they're off, they face.
Like a Federal Pacific.
Yes, like a Federal Pacific.
Yeah, that's allowed.
Okay. So this is the example.
You're not talking about a vertical installation.
Here.
You're talking about a horizontal installation.
Yeah, Harris,
there's no pressure on it.
Yeah. So look at this panel here. See how all the breakers are facing into the middle?
Right. And they're all on.
They're on. Let's go back to this one. The top one is wrong because it's down is on.
Yeah.
Is it wrong or not?
Yes, it is wrong.
Thank you. Okay. So this one here, is this back fed?
Yes. You can see the screw holding in the main breaker. That's back feeding the panel.
Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Do they make a panel with 18 poles?
Yeah, they do. They make panels, like I say, up to 40 circuit breakers.
Okay, but this panel here may not be rated for 18 because we look at the door and the door would tell us.
That's exactly right. You'd have to read the door to see if it's a proper application.
Okay, is this on the inside or outside of the house?
This is on the outside of a house, and it's not a rain-tight panel.
Okay, so take a look. You can see here's outside siding, and this panel box here is for inside it's not weatherproof. So they've used the wrong box in the wrong location. Good catch, Harris. I'd hire you as an electrician any day. Okay. Okay, this panel here, this one is not sideways. I just took it that way. Sorry. Here, let's make this straight. There you go. Feel better?
Much better.
Okay, I feel better. So Harris, this big breaker at the top, is that correct?
Yeah, that's a main 200 amp breaker, and it's properly secured into the panel, and it's feeding the bus bar.
Okay, so take a look at the bus bar up here and you notice the bus bar is a flat piece of metal with no V-shaped mark
Notches.
in it, no notch. So let's go all the way to the bottom, and you see here the notch in the bus bar. Zoom in,
Right.
zoom in so you can see it. So that means if I have breakers that are like these twins up here, they can only be on a bar that's notched. So right here, there's no notch. So that means these breakers can't be any higher than where they are. Cool. So 1, 2, 3, 4, 5, 6. So in this panel, I'd have to check because I've been checking on it to see. Generally, I find out it's five full-size breakers up is where these go. So I'd have to pull one of these, which I'm not doing at the inspection. But generally, it's been 5, and sometimes it's 6. Harris can talk to that depending on the brand. But these breakers here allow 2. What size breakers? This is the blue here is what?
Blue of 15 amp, red of 20 amp.
Okay, so is that 220 volt circuits then?
Right, that's 220 volt circuits. They're both on the same phase, the same bus bar. So you can't get 220 out of a breaker like that.
Cool.
Two 120 volt circuits.
Okay, so up here they took a white wire, but they put a piece of tape around it. They're not trying to hide anything. They're doing that because they have to mark the wire for its use.
That's right. Now it's identified as a current carrying conductor.
Cool. So if I'm an inspector, I'm just looking through this thing. Do these 2 breakers, are they the wrong brand installed in this panel?
Well, they're the wrong brand, but they look like they fit properly.
Well, sure they do. I break off the safeties and jam them in there with a hammer. They fit perfect. Okay, are they the wrong brand for the panel?
Well, here's where it gets a little technical.
Yes or no?
The only reason you want to have the same brand circuit breakers in that brand panel is for a warranty, which lasts exactly 1 year.
Yeah, I know, Harris, but for us.
But it depends on the panel. They will tell you what's acceptable as other brands that are acceptable to be put into the panel.
Yeah,
so it's no longer only one brand in one panel.
Yeah. So today, if we see a mismatched brand in the panel, is that wrong then?
No, not necessarily.
Okay, Harris doesn't know. Harris doesn't mean it. Harris wants you to write it up, and then electrician can say it's okay, just like he's saying. But how do we know that multiple brands can be in that panel, Harris? That's the question. That's the answer to this. Answer that.
If you look at the door of the panel, it will tell you also the different types of circuit breaker brands that are acceptable to be put into the panel.
That's what Harris has been saying to you. That's what he means when he says these can fit in there, because it says right on the door, on that thing, the label thing that's on the door, it says it right there. And many of you are using something called a camera on your tablets or your phones, so you can take a picture of that and embed it in your report. Okay, Harris, I have another question for you. Can I double tap into that breaker right there? See those 2 wires?
No, you can't. You cannot, because it's a single screw without a tab that goes across the back.
Okay, he only knows this because he recognizes it. Like some of you say, oh, I see a car, and you know the brand.
Yeah.
Okay.
It's a brand panel that you're looking at.
Save. Okay. Oops. Cancel. Boop. Okay, here we go. So we just looked at, it's out of focus. Okay, here we go. Okay, Harris, I see this pasty stuff on this multi-strand aluminum wire. Why?
Right. That's called antioxidant. It keeps the wire from oxidizing from the air.
Now,
aluminum wire will oxidize when it's in the air without protection.
Oh, cool. Okay, now I'm noticing here all these holes of different sizes and stuff. Is that so I can put a bigger neutral wire in them?
Yes. In other words, it's made different sizes for different size wires.
Okay, so I don't see any markings on here that tells me I could put 2 wires in the same hole. Where would I see that? Where would it tell me to do that?
Again, you look at the door of the panel where the where that catalog is, and it'll tell you how many wires you can put under each particular screw and what size wires are accepted from the smallest to the largest.
So Harris, is it generally one neutral per lug and then multiple grounds can be installed?
Yes, that is normally the way it's announced.
Okay, why? Why don't I want to put the same neutral and the same ground under the same lug?
Well, because it may not have a good connection, and if it doesn't have a good connection, it can cause a really big problem.
What would that be?
Somebody can get electrocuted, lights could flicker,
Okay,
a fire could start.
yeah. Did you hear the part about electrocution, everybody? It's a killer because it's wrong. So we don't want to underestimate the important part of that. Okay, now for extra credit, I'm going to zoom in really close, and it says dryer and range. So I'm going to have to believe whoever wrote that. If I look over at the dryer, what's wrong?
Well, they're 20 amps.
20 amp.
20 amp. Yep, you gotta be quicker there, Roger. Old Harris there, he's ready to go. 20 amp, and it's missing the double tie bar too. See, everyone always wants to say, "Oh, it's missing the tie bar." It's not missing anything. They're 20 amp breakers. It's wrong, right? Wrong. The range.
If it's a dryer.
It's a dryer. And what size do I need for a dryer, Harris?
30 amp.
30 amp. Yeah, there you go, Roger. That's right. Crush him.
There you go.
Crush him.
You did it.
Yeah. Okay, here we go. And, you know, this is the one I wrote up, and the electrician said it was fine. I had to go out there, and I said, are you kidding me? Okay, it's a piece of hose cut so this wire laying over this other one that's all burned. It's out of focus. I wish I had spent more time, but I was scared of getting shocked. It's burned the panel, everybody. It's changed the color of the breakers from the fire. And it wasn't making any noise, but I don't know how it was working. The oxidation was pretty bad. Either way, it's bad. So they did replace the panel after I walked out there and talked to the electrician. Harris, how do you write this one up?
Panel needs to be replaced
Why?
because of burnt wires and burnt bus bar.
See how easy that was, everybody? You got to tell them what it is, because everyone says, oh, there's unsafe conditions, and that's all they say. And then you look at the report and you're going, you mean that double tapped wire? You know, and then here's something like this, you know, incredibly obvious. Okay, here we go. They love to put these double breakers here. Is this a square D panel, Harris?
Well, it's got a square D breaker in it.
Oh, see, now suddenly, yeah.
Well, no, actually, those are square D breakers on the rest of them, the doubles.
Yeah, so right here, they're the same brand, but they're just a different style. Okay, but here's your double handles, and there's a single, but they say 20s. So let's do this one right here, Harris. It's easier to read. It says 2020. Is that 40 amps, or is that two 20 amp 120 circuits?
That's two 20 amp 120 circuits.
Cool. Okay. Look at that. Oh, 2004. Harris and I went somewhere.
Hey.
Okay.
That is a Sylvania or Zinsko panel. And the bus bar on that panel is aluminum. And the connections are aluminum. And the wiring to the breakers are aluminum.
I can't see that in this picture. I can't see other than multi-stranded here. I can't see it because the paint's in the way.
Right. Now, anytime you have a painted panel and I hate to use the word code, the panel is rejected. It's not good any longer because you've changed the composition of the panel.
Does the manufacturer allow you to paint inside the panel?
No, they actually give you a mask that goes in the panel, covers all the bus bar and the whole interior, so that when the painter paints, he can't paint the inside.
Okay, so the answer is no.
Right. No paint in the panel.
Thank you. Okay, Harris, I got a big breaker here at the bottom. It has the number 6 or 9, depending on which way I look at it, and 20 right here, and then a 20 amp breaker. They're both 20 amp breakers. Why is this one so gargantuan? The other one's sort of like a shrimp. What's up?
Okay, well, The little guy is for 120, 240 volts.
Oh, cool.
The big guy is for 277 volts.
Is that something we'll ever see as an inspector doing a house?
No, you'll never see that in a house ever.
Okay, there you go. So if you do see it in a house, something's wrong.
Right.
Okay, thank you. Okay, again, I like breakers that are burned. We'll skip that. That says SPA, says 50 amps. And then it's got a GFCI right there, Harris.
Right. And that's a part of the installation that has to be done. The GFCI must protect every spa.
Should, under the standards of practice, am I required to push that yellow button to determine that GFI works?
Yes, you are, because it's a GFCI. You must test all GFCIs.
It's weird. In the standards of practice, it says you must test all GFCIs. And if you don't, what are you supposed to do, Harris?
Run.
Yes, I know. What do you write in your report, Harris?
You write in your report that you didn't test it for whatever reason you have.
Thank you.
I didn't find it. I didn't.
Yeah, so in this case here, you'd say, I didn't trip the 50 amp breaker off of the GFCI because it was already off.
Well, if it's already off, you indicate that the GFCI breaker was in the off position and you didn't test it.
Can't I just go ahead and flip that on?
Never turn on a circuit that's in the off position because you don't know why it's off.
Wow. Now, Harris didn't argue. He just answered that right away, everybody. And that's true. Thank you, Harris. So here's some sort of box, and it doesn't look like it's hooked up to me. I think it was just laying there, and I can't remember. I think the guy that did the inspection said GFCI breaker not working, and I'm going, well, it's not even hooked up. It's just laying there. So I took a picture. Again, this is oh, that's that big breaker. So we'll skip that. Okay, for extra credit, oh, well, I already did this one earlier, Harris. They all know it's a split bus panel. Okay, so C is the split bus. B is what, Harris?
B is a 2-pole breaker.
Thank you. A is a
2-pole breaker.
Okay.
With an internal trip.
Okay, and I look at D here. I see the 2 wires, and that's what?
Those are twin breakers.
Okay.
Or half
breakers. Is in this case they're in one full size breaker space.
Right. So they're 2 120 volt breakers.
So it's 2 separate circuits.
Right.
Okay. And E is what?
E is a single 20 amp breaker.
Okay. So when I take a twin or a tandem or whatever we're calling it based on the brand, it fits in the space of a full-size breaker, but allows me to get another circuit.
That's correct.
Okay. I hear all these people on the internet and all the experts calling them cheaters. Is that a technical term for these breakers? Cheaters?
No, they're not cheaters. It's a legitimate type of breaker that's UL approved.
Okay.
For the purpose.
So they're designed to be in there.
That is correct.
Thank you. Okay.
Now, were you talking already about E, if you go back?
E?
E.
Yeah, you said it was
F.
a single pole.
C.
Oh, F, I'm sorry. F, go ahead.
Well, F, what they have there is circuit breaker A is the feed for the sub panel on a split bus panel. In other words, that's the main breaker for all those circuits that are below the wires. But that double wire is not allowed. It's called a parallel wire, not allowed. Against, and you see a burnt connector right there. That whole panel should be replaced.
Bad.
Bad.
Okay, here's a close-up of a quad breaker, quad. And we talked about this before you got on. Copper aluminum. This does not have an internal up here. It shows you.
Nope.
It doesn't have internal. I bought 2 of these today, Harris. To fit.
Yeah, that's why you have that metal thing, because that metal turns both breakers on and will turn both breakers off if they trip.
Right.
That is an approved type 2-pole breaker.
240 volts.
240 volts, 30 amps on the outside, 50 amps on the inside.
Okay, this one's all washed out by the sun, but the idea here is I have two wires hooked up, and when you look at this here, let's zoom in. Okay, so when I look here, I see this location where the screw is. There's like a little rounded space here on a plate, and the wires fit in perfectly. So are these designed to have two wire connections?
That is designed to have two wires in that connection, yes.
Cool. But I don't know that these two circuits aren't running like the microwave and something like the refrigerator. How do I know if these are wired properly?
Well, yeah, I mean, you don't know, and at that point, you don't care, because if the circuit breaker is holding, not tripping, then it's not overloaded.
Okay, so if I was hooked to two bigger items, it would be tripping, and I'd have nuisance tripping all the time.
That is correct. It would never stay on. You'd always have a problem.
See, everybody? There you go. There's a simple way. You just say to them, well, when this keeps tripping, I guess it's wired wrong. See?
Yep.
Okay, this is the mechanism showing you a polarized receptacle with this yoke here. And then you can see one side is small and one is big. The small side is always what, Harris?
The small side is always the live side, or the hot side.
With brass screws.
Colored screws. And the other side is the neutral, and with silver colored screws.
Okay. And so when we have to check for polarity as required under the SOPs, we're checking to make sure they've installed the wires correctly.
That is right.
Okay. So this space here and this yoke, if I test off the hot side and touch any of this metal, what should I get?
You should get a light that lights up.
Okay.
Or a meter that shows power.
Power. Thank you, Harris. But if I touch the larger side, which is the neutral, and any of the yoke and outside, what's going to happen?
Nothing. You won't get any reading.
I'm not going to get continuity?
Well, if you use a continuity tester, yes.
Ah, there we go. So I have to use a continuity tester, but a standard tester that's just testing for power will show nothing.
Right.
Okay. Harris, I want to know between these two screws, what is this plate across these two screws right here for?
Okay, that little plate could be broken off so that you could isolate one receptacle from the other and have one switched and one with power on all the time. When you get into a house and you find a switched receptacle, they break that little tab off on the top, and the top receptacle is typically the switched receptacle. The bottom is usually with power on all the time.
Cool. So on the other side is where the neutral wires are connected, and there's also one of these bars here. So that would generally be connected, and this one would be broken loose.
Right. You only break off one side where the power is for the switch operated receptacle.
Cool. Okay, Harris, I'm staring up at the service panel, and I see this 2-inch pipe. So it must be taller than 2 feet.
Yes.
Because I have these stanchions here on the back side of it.
That's correct.
Okay, that's B. So A, I see this connector here. Should that connection be something that the power company put on? Or can that just be something wrapped with some tape and be okay?
Oh, no, only the power company can make that connection. And if an electrician makes his connection, the power company has to replace it. They use compression type connectors.
Okay. I'm not sure. Someone was using a special name for that connector, and I'm going, who cares? Do you happen to know what that connector is called?
No.
Oh, anybody know? No electricians on tonight? Okay. It has some name, but someone was kept blabbering about the name. I'm going, whatever. Okay. So
I mean, they use Burndies, and Burndies are a brand.
Okay. He came up with the brand of Burndies. Yeah. So that's what the guy was, yapping about. It's a brand. Okay. So Harris, A, what's wrong with A?
Well, there you have your roof jack or flashing, not installed properly.
Okay. How about B?
B is the old connection where the point of attachment was from the original old service.
Okay, so
And
POA.
that's where the conduit, that was where the conduit was that went down to the panel,
Okay, and then over here, here's my POA.
right? Point of attachment.
Yeah. Please, when you're talking about, when you're, I had another meeting going on. When you're talking, stop using these letters in your inspections. Nobody has a clue what you're talking about. So I had to read a report. And he kept talking about the POA and point of attachment, you know, and I kept saying, if I don't know what it is, how can the person you're dealing with? Okay, Harris, this light fixture here has wires coming across here, but they seem to be strapped up there, so they must be okay.
They're not okay because, again, they're subject to physical damage.
Okay, and then I got a stair step crack here where it's wood right here. I'll just let everybody know it's wood right here. There's probably a wood lintel, and then I have block here, so that gap is probably not an issue. And then exposed wire again, right?
Right.
Okay, so okay, Harris, this circle here, what's wrong with that fitting?
Well, there's nothing wrong with the fitting called the Spiedel.
Well, you're going to make me zoom in.
Yeah.
Okay, thank you. So I have compression connectors on the end, so that's okay?
That's okay. And underneath the back plate is a gasket.
Oh, here.
Black thing. Yeah. Right there.
Okay.
There's a gasket. Yeah.
So this conduit, does it have a name?
EMT.
EMT?
Electric metallic tubing.
Okay. And then I see a piece of Romex coming out of the wall here and running up and running along. Is that okay, or should that be in conduit?
That's supposed to be in conduit also.
Okay. Then I have this light fixture, and I can see the fixture inside this thing is broken off and laying to the side here. Is that bad?
It should be replaced.
Okay, so it's bad. Can I run a piece of conduit up and just stuff the wire underneath this outlet here?
Nope, not a proper termination.
It's still bad, everybody.
Right.
Tell me what it is, and then I have exposed wires, and I use my volt stick, and I just whip it out. I put it on there and say, this wire has power to it. And then that outlet, it's outside. Should that be GFI protected?
Supposed to be.
The answer is yes, and it's supposed to be. Okay, here
Yeah,
we are.
but that outlet wasn't GFI protected. Didn't have a GFI in it.
Yeah, it doesn't
Because
have.
that cover wouldn't allow a GFI to be installed.
Yeah, it's outside because I see some stucco. Can one GFI control many receptacles?
You could put as many as 10 receptacles on a GFCI
Why can I do that?
because it's up to the amount of power that's going to be used when people plan or design a house.
That's too much talking. Tell me why.
Well, you're allowed to have 180 watts per receptacle,
Thank you.
and that's the number you got to use if you're designing.
Okay, thank you.
You cut me off on one end, and I answer the same way in another.
I know. I love it, Harris. Thank you. You're the best, baby. So it's 180 watts. We'll move on. Okay, here we are at a commercial building or whatever it is, and here's a driveway. So you measure from here up to the lowest point to determine if we have our amount. Is that correct, Harris?
That is correct.
Okay, and that amount over a driveway or a street or an alley needs to be how high?
18 feet.
18 feet. It's an exposed wire with the outside insulation gone.
Right. That's a cooler box.
Here's exposed THHN run along. Bad.
Bad.
More bad under a counter.
More bad.
More
Bad. Bad.
Bad.
Bad.
The panel's coming loose. That's not supposed to be a triangle. It's supposed to be two arrows stuck together. They notched this out with, I don't know, maybe they had a beaver gnawing on the wood there or something. Weird. Okay, wire sticking out of the wall. There's your burn panel. We've gone an hour and a half. We zoomed right through it. Does anybody have any questions? Harris, anything to say?
Nope. We did good, I think.
Yeah, we'll make sure you get a link. We could do electrical every Tuesday for the next month and a half and never show a picture twice, I think. I want to thank everyone for coming on tonight. We can send you this link. Does anyone have any specific questions? Roger, do you?
No, thanks again for an excellent show here. I
Okay.
appreciate it.
So we can focus on panels or subpanels or exterior. Okay, so that everyone realizes we're one of the few states where the main disconnect and all the breakers are outside. Back east, the meter's outside and everything's in the basement or in the garage. So when we show them pictures like this, they all freak out. Well, the new codes, and Harris can speak to this at our next class, they want to disconnect somewhere near the meter so that they can disconnect without having to run inside or pull the meter. Harris, anything you want to say to wrap this baby up?
Nope, everything, it was a nice presentation. I think we covered a lot of ground, and hopefully people picked up a few items.
Okay, so we could do more electrical. I don't know what we have in the tube here for going for the next couple of classes, but we've only advertised this for like 2 days. We just started Friday when Harris and I decided, hey, let's do a class Tuesday. So I want to thank everyone who came. Brad, Harris, Jamie, Key, Richard, Roger, and Steve. There was someone else on, but we lost him. I think he fell asleep and his phone fell out of his hand or something. Okay, thanks everybody, and have a great week. Thanks a lot.
You too.
Okay,
All right, thanks,
bye-bye.
Greg.
Thank you. Good night.
Hey, Brick, the game goes on at 8:30.
Yeah. Oh, Harris, call me. Call me in a minute.
Call you in a minute.